So, good morning. So, here's my topic. It's all about Scheffe Test. Okay, so what is the Scheffe Test? Do you have any idea? Or is it your first to encounter this kind of test? Just like me? Okay, so here. Let's take a look at this. So the Scheffe test is also called Scheffe's procedure or Scheffe's method. It's a post hoc test used in analysis of variance. So gamitin siya sa one of the post hoc tests. And then it is named for the American statistician whom is Henry Scheffe. So after you have run ANOVA and get a significant F statistics, you have rejected the null hypothesis that the means are the same. Then you run Scheffe test to find out which pairs of means are significant. So you need to use the Scheffe test in order to find out which pair of means are significant. So the Scheffe test corrects alpha for simple and complex mean comparisons. Complex mean comparisons involve comparing more than one pair of means simultaneously. So out of the three mean comparisons test, you can run the other two are Fisher's LCD and Tukey's HSD. But the Scheffe test is the most flexible, but is also the test with the lowest statistical power. So deciding which test to run largely depends on what comparisons you're interested in. So if you only want to make pairwise comparisons, run the Tukey procedure because it will have a narrower confidence interval. So if you want to compare all possible simple and complex pairs of means, run the Scheffe test as it will have a narrower confidence interval. So in calculating the test, only run this test if you have rejected the null hypothesis in an ANOVA test, indicating that the means are not the same. Otherwise, the means are equal and so there is no point in running this test. So the null hypothesis for the test is that all means are the same. And this one, the alternative hypothesis is that the means are not the same. So mauna siya ang kuwan. So this test is usually calculated with software. Like most statistical tests, you find a critical value and then compare it with the test statistic. Reject the null hypothesis if the Scheffe test statistic is greater than the critical value. So the steps that follow are for calculating simple pairwise comparisons by hand for 4 samples A, B, C, D. You'll need descriptive statistic data. So the sample means plus data from the like mean squared error. So here is it, A, B, C, D. So sample means for samples, we have here A is equals to 36, and then B we have 34.50, and C for 35.60, D 36.21. So ANOVA data from the ANOVA output, F value is equals to 3.24, and then mean squared error 0.028. So here's the step. Calculate the absolute values of pairwise differences between sample means. So you'll have to figure out all the possible combinations for example, there are 6 possible combinations of 2. So AB, AC, AD, BC, BD, and CD. So for example, for AB, the absolute difference is AB is 36 minus 34.50. So the value of A is 36 and the value of B is 34.50, so equals to 1.50. So step 2. Use the valuing formula to find a set of Scheffe formula values. You will use this in the next step. So mauna na siya. Where K minus I is the between samples degree of freedom. For this set of data, that's 3. Then 4 minus 1 is equals 3. So I don't really know how to read those symbols in mathematics. So You can just watch this data again in my handout or in the PowerPoint presentation. I mean my PowerPoint presentation. So we have here step 3, compare the values in step 1 to the values in step 2 and find any values that are larger than the comparison values. Larger values are statistically significant at a certain alpha level. So in this case, it's 0.05. For the sample, the only value that isn't significant is AB because 0.21 is smaller than 0.30. So I have another video presentation from YouTube so you can really understand what my report is all about. Okay, so thank you. Have a good day, everyone.